Okay, so example 3 is where we left off with part 1, and we want to find the value of x for the right triangle. So they give us this triangle here. This time we have a 30-degree angle. So that means we're going to have to use that chart. So from 30, x is going to be the adjacent side, and 8 is the hypotenuse. The good thing about these is we're not finding all 6 trig functions, so we don't have to do the Pythagorean theorem to find the third side. All we use are the things they give us. So from 30, x is adjacent, 8 is hypotenuse. Which trig function uses those two sides? Cosine. So cosine of 30 is going to be x over 8 because it's adjacent over hypotenuse. And instead of theta here, we have 30. We know that angle, so that's what we put in there. So if you look at that chart, I guess I should show you step 1. You ask yourself, what sides do you have from your angle? Step 2, what trig function uses those sides, which I already asked you that. Okay, so cosine of 30 on your chart is the square root of 3 over 2. So you'll write that, and it still equals x over 8. Okay, we want x by itself, so we multiply both sides by 8. And if we have 8 times the square root of 3 over 2, 8 and 2 reduce. 2 goes into 2 one time, 2 goes into 8 4 times. So then we'd have 4 times the square root of 3 over 1, which is just 4 square root of 3. So take a minute to make sure you understand how to do that one. Can't believe you eat it. Okay, so finding all unknown side lengths and angle measures of a triangle is called solving the triangle. So solving right triangles that have acute angles other than 30, 45, and 60 may require the use of a calculator. So on these, if you don't have your own calculator, you can either use the virtual one on your tablet, or you can go to that meta calculator link that I put on Schoology. Okay, so it says to be sure that your calculator is in degree mode. So you might have to change it, but make sure it's in degrees. All right, so we want to solve triangle ABC for example 4. So step 1 is to write what you know. So we have big A, big B, big C, and then little a, little b, little c. Here's the triangle that they give us. Big A is 28 degrees, so we know that. So capital letters represent angles and lowercase letters represent sides. Now if you notice, the sides are directly across from the angles they represent. So side A is directly across from angle A. Side B is directly across from angle B, and side C is directly across from angle C. You'll also notice that C is always 90 degrees for the ones that we're using or looking at. What? Come here. We also know that side B is 15, so we can write that. Come here. Okay. So step 2, after you write what you know, you use trig to find the other sides. So we have, if we want to find angle B first, okay, if we want to find angle B first, you can do it one of 2 ways. We know that the angles in a triangle add up to 180 degrees. So you can either add these two together, 20 plus 90, and get 118, and subtract from 180. So you have 180 minus 118 is 62. So you can do it that way. Or since this is 90, these two angles also have to add up to get 90. So if you just do 90 minus 28, you'll get 62 as well, which is probably much simpler than this. Okay, so to find side A, we use what we know. So we're going to use 28 and 15 from our triangle. So from 28, side A is the opposite and side B is the adjacent. So we have tangent, because tangent uses opposite and adjacent, and you use the angle they give you. So tangent of 28 is the opposite over the adjacent, which is A over 15. You're okay. So if we have a over 15, we want to get a by itself. We multiply both sides by 15. Those will go away, and we get 15 tangent of 28 equals a. So if you type in 15 tangent 28 in your calculator, it'll give you a is 8. And it might be a decimal, and I might have rounded to 8. I don't remember. I think it was. Okay, so a is 8. Now we've got to find c. So using the same triangle from 28, we have 15 and c. 15 is adjacent, and c is the hypotenuse. I don't know. Hold on. Here, Campbell. Watch Frozen. Okay, so to find c, we have the adjacent and the hypotenuse. Adjacent and hypotenuse is cosine. So we have cosine of 28 equals 15 over c. So we always multiply by whatever's on the bottom. So in this trig function, it's 15 over c, so we'll multiply by c and get 15 by itself. So that gives us c cosine of 28 equals 15. Now, to get c by itself here, we would divide both sides by the cosine of 28. So you have 15 divided by the cosine of 28. And if you put that in your calculators, you get c equals 17. Oops. So c is 17. Okay, there we go. All right. So that is solving a triangle. We know all the sides, all the angles. Okay, so MP 3 and 4, I want you to try number 5 right here. So try this. Actually, I'll have you try it in a second because this one has 45-degree angle. So that's going to be a special triangle, which we'll have to use that little chart. So from 45, x is adjacent and 6 is hypotenuse. So adjacent and hypotenuse is cosine. So you have cosine of 45 is x over 6. Before we multiply by 6, we need to find out what cosine of 45 is. So cosine of 45 is the square root of 2 over 2, and that equals x over 6. Now we can multiply both sides by 6, and we get x equals 6 square root of 2 over 2. 6 over 2 reduces to 3, so it's 3 square root of 2. Alright, this is where I want you to pause and try to do these by yourself. I'm only having you do 7 and 8, so mark out 6 and 9. Alright, so with 7, it gives us a is 32 and b is 10. So we know a is 32, little b is 10. Okay, we also know that c is always 90 degrees. So to find b, you can do it this way, or you can do it 90 minus 32, which will also give you 58. Quick, Campbell. Alright, so now we want to find a and c. Also, if you draw your own triangle, this is what it would look like. So a is 32. And then side B, which here's angle B, so it's this one, is 10. So we want to know these two sides. Alright, so let's find A first, which will be this one over here. So if we have 32 and 10, from 32, side A is the opposite and 10 is the adjacent. So we have up here, tangent of 32 is A over 10. To get A by itself, we multiply both sides by 10. And in your calculator, you'll type in 10 tangent of 32. And that will give you 6.2. So if you have a decimal, round to the nearest tenth. Campbell is making the sound of a horse. Okay, so A is 6.2. Now we want to find C. Let's uncover this. That's A. Oh, and this one is C because C is directly across from capital C. Okay, so to find side C, we know 32 and 10, and we want to know C. So from 32, 10 is adjacent and c is hypotenuse. So we have cosine of 32 equals 10 over c. So if anytime the variable is in the denominator, instead of multiplying by that like we did on tangent of 32, if c is in the denominator, whatever variable you're solving for, you divide. So you do 10 divided by cosine of 32, and that'll give you 11.8. So c is 11.8, and you've solved that triangle. So for 8, I'm going to start uncovering things. This is the triangle that you draw. This is what it should look like, because we want little a to be across from big A and little c to be across from big C. So we know that A is 71, and we know capital C is always 90. And then in this one we have little c is 20, so we know that. Okay, to find your third angle, remember 90 minus 71, that'll give us 19. Or you can do it this way. I don't know why I wrote it out that way. Okay, we also need to move this. I don't know if you can see through it. Let's go up here. Okay, so we want to find A and B. Let's find A first. From angle A, 71, side A is opposite and 20 is hypotenuse. So opposite and hypotenuse give us sine. So we have sine of 71 equals A over 20. 20 is in the denominator, so we'll multiply both sides by that. So multiply both sides by 20, and you will get 19 equals A. Okay, so side A is 19. Now we want to know side B. So B from 71 is adjacent. 20 is still the hypotenuse. What are you doing? Alright, so adjacent and hypotenuse gives us cosine. So we have cosine of 71 equals b over 20. 20 is still in the denominator, so we'll multiply that by that. So you'll type in 20 cosine 71, and you get 6.5. So b is 6.5. Alright, last page. Let me move this again. Alright. So it says, example 5, you're hiking near a canyon. While standing at A, you measure the angle of 90 degrees between B and C as shown. When you walk to B and measure an angle of 76 degrees between A and C, the distance between A and B is about 2 miles. How wide is the canyon between A and C? So luckily they drew us a picture already. What you can't see in that picture is A is the 90-degree angle, but it also says that. And it says that you measured the angle of 90 degrees between B and C. So when it reads like that, between B and C, that's the angle that almost points to it. So A, if you go straight across from A, it'll be on the line BC. So here's what they give us. So from 76, we want to solve for x. From 76, x is opposite. And remember, if A is the right angle, then 2 is the adjacent, because the hypotenuse would be over here. So we have opposite and adjacent, which gives us tangent. So we have tangent of 76 equals x over 2. Okay, this is not a special angle, so we can just do our calculator stuff. Multiply both sides by 2, and we get x equals 8, and this is in miles. Okay, so down here, this is the last thing that I looked at on the very first video I posted. So it says, if you look at a point above you, such as the top of a building, the angle your line of sight makes with a line parallel to the ground is called the angle of elevation. And then at the top of the building, the angle between the line parallel to the ground and your line of sight is called the angle of depression. These two angles have the same measure. So this is like that little picture I drew of your stick person and then at the sun. So the line from your line of sight looking up to the sun is angle of elevation. From the sun down is depression. But I also said that anytime you're dealing with angles of elevation and angles of depression, always put them in the same spot. And we're always going to put them at the bottom right bottom right angle of the triangle because they have the same measure. So it's not going to matter. This up here is not the